Okay, so today what we're going to be looking at is we're going to be looking at tangents. Okay, now we have this covered in class quite some time ago, but I'll go over it again nonetheless just to refresh your mind. Now, a tangent is basically a line that glances off a circle at one point and one point only. So, say for example, we'll take our first centre here, we'll take our first circle here, this is its centre point, and we'll point out here, we call it point P. Now, if I were to get my ruler and align it so that it just glances off our circle, so it's sort of coming down, it's just going to glance off it there, and this line only strikes our circle here, and then it glances off, that point there is known as a tangent, and the point that it strikes it is known as a point of contact. Now, while that tangent is correct, the constructions in it would not be acceptable in an exam. So we'll be looking at the correct constructions that you can use to locate the point of contact for a tangent to a circle from an external point P. Other types of tangents then that you may come across include an internal tangent, which is where a tangent runs inside two circles. We'll be looking at that in a forthcoming video. And also an external tangent, where a tangent glances off both circles along the outside. So that's your tangent from an external point, your internal tangent between two circles, and an external tangent between two circles. So in this first video we're going to focus on how to draw a tangent to a circle from an external point P. And this is the most basic tangent construction you can get. Now, the first thing to do is to join your point P. Well, we have to find our point of contact, and it can either be above or below the centre line. Okay. Now we can guess. We can say that, right, well, there's going to be a point of contact up here. There's also going to be a point of contact down there. But how can we find the exact location of our point of contact? Well, the way to do it is starting off is to join your point P through the centre of the circle, we call it C. Okay, now the next thing we do is we have to bisect this line segment running from P to C using our compass. And what we do is to bisect a line, you set your compass to a distance which is more than half, okay, between the line you want to bisect. In this case it's PC. Okay, now it's important you keep your compass set to that distance and you strike an arc above and below the line using P as a centre. You're going to use C then as your second centre and repeat the process, striking an arc above and below the line. Now where those arcs cross here and here will give us 2 points on our bisector, and that bisector is used, now it just so happens to be on the circumference of our circle here, but that gives us the centre of our semicircle. Okay, so it basically bisects that line segment, and now we can draw our semicircle running from C through P. That will give us our point of contact above the line, which will lie here. Okay, and similarly, if we repeat the same process below the line, that will give us another point of contact there. Now it's important in the exam, okay, that you highlight the work that you went to in finding those points of contact. Don't rub out your constructions. Don't draw them too dark either, I suppose, but don't rub them out certainly. And also highlight your point of contacts by going over them darker. Okay, and label them as well. Very important. So what we can now do to finish drawing our tangents is we can go to our point of contact, turn it back to our point P. Okay, and we can see there that yes, indeed it is a tangent, as it only glances off our circle at that point. And similarly, if we were to join from our point of contact into C, okay, that can also be verified as 90 degrees, because any angle joining the ends of a semicircle to its circumference forms a 90-degree angle. Now, I have 2 more videos coming up on the construction involved in drawing an external and an internal tangent. Thanks for watching.